Hello students, in this question, I is a unit vector due east and j is a unit vector due north. Distances are measured in kilometers and time is measured in hours. So it says that at 9 a.m. a ship leaves at point P. Its position vector is 5 plus 16j relative to the origin. It sails with a constant speed of 6 root 3 on a bearing of 120 degrees. So show that the velocity of A is 9I minus 3 root 3j. So the velocity component, which has been mentioned over here, is 6 root 3. So if I'm talking about the x component of this velocity, so that should be 6 root 3 into sine of 60 degrees. And if I'm talking about the y component of it, so that should be minus 6 root 3 into cos of 60 degrees. So 60 degree, which we got, is 180 minus 120. So that's the component which we have used here for 60 degrees. So if I really put down the values over here, so for the x component, sine 60 is root 3 by 2. So that means 6 root 3 into root 3 by 2. So this gets cancelled. So this is 3 and we got it as 9. So we can write it as 9i. That's the x component. If I'm writing about the y component, so cos 60 is half. So that means we got it as minus of 6 root 3 into half, and if this gets cancelled, so that's equals to minus of 3 root 3 j. So the value of the velocity that we are required to prove in the A part at point A is equals to, if I simply add the components, so 9i minus 3 root 3j. So that's the answer for the first part of the question. They've asked find the position vector of A at 12, right? So it starts at 9, so at 12, so we have 3 hours of the journey completed. So the answer to the B part is the initial position vector, which is 5i plus 16j plus the 3 hours, which should be multiplied with velocity, because time into velocity gives you the distance. So we can write it as 9i minus 3 root 3j. So that will be the distance or the position vector after 3 hours. So the value that we got for this, if we solve this out further, we'll get it as 5i, and this is 27i. So that's 32i, and 16j, 16 minus 3 root 3j, or rather 9 root 3j. So that's the position vector answer for the B part. Now, the C part of the question says, at 11, B leaves a point Q with the position vector this. It sails with a constant velocity with this. I write down the position vector B in t hours. So again, we'll use the same formula that time into velocity gives you the distance. So if I'm responding to 8C part of the question, so we'll first write the initial position vector, which is 29i plus 16j. And to that, we'll be adding the t times the velocity component. So this is t times minus 12 root 3j. So that will be the answer for the C part of the question. Now, D part of the question says, find the distance between the two ships at 12. So the ship is leaving here at 11, and they have asked for the distance between the two ships at 12. So to respond a D part, we'll put t equals to 1. So that means we'll first put up the initial position vector that we got for this, which is 32i plus 16 minus 9 root 3j. And from here, if I put t as 1 over here and simply subtract this, so if I'm putting t as 1 over here, so that becomes minus 29i, and t as 1 means we got it as plus 16 minus 12 root 3j, and this should be a negative sign here. So if I'm subtracting these two vectors and if I'm finding the modulus of this, so the modulus that I got is root under of 3 square plus 3 root 3 whole square. So that's equals to 6 kilometers. So that will be the distance between the two ships after an hour. So if now I go for the marking scheme explanation for this, so you get straightforward 2 marks for this calculation. You get 1 mark for writing the expression correct. You another get 1 mark for writing this correct. Now 3 marker, this is the first mark you get if putting t equals to correct and getting this subtraction done. 1 mark for writing this and 1 mark for the final answer. So that's the marking scheme for this. Thank you, students.